Careful, I'll give you an example. This is an interesting example given in OpenHAM. Suppose we consider a signal xt is equal to e to the power minus at, let's say t less than or equal to t less than 0 and 0 otherwise. It is a finite duration signal. Can you tell me what is the Laplace transform of this signal? How to find the Laplace transform? The expression is x of s is integral minus infinity to infinity e to the power minus at into e to the power minus st dt. That is how we find the Laplace transform of a signal. So what is the Laplace transform? Does it have a Laplace transform? What is the condition for existence of Laplace transform? This is a finite duration signal. What should be the shape of the ROC if it exists? It should be a two-sided entire S-plane, isn't it? It is the entire S-plane. Now, if we compute this integral, you will get, I think you will get, sorry, this is minus infinity to infinity, and if you put this integral will become 0 to t, and when you do that integration, it is e to the power minus s plus a t 0 to t divided by minus s plus a. Is it? This is the integral. When you compute this, you will get 1 minus e to the power minus s plus a into t. Okay. That is straightforward. Now, what is the shape of the ROC? It is a two-sided signal. The shape must be what? The entire S-plane. Okay. Now, is it true here? There is another condition. Pole cannot be inside the ROC. Does it have a pole, this function? What is a pole? If we consider rational system function, write it as a ratio of two polynomials, then roots of this denominator are called the poles. Okay. Is it a pole? What will happen at a s equals minus a? If it is a pole, then it must be what? X of s must be? It is a root of the denominator polynomial. When it is means root means if you put that value, this function will be 0, isn't it? So x of s will be infinite at a pole. Now, is this a pole?
No, sir.
No, it is a root of this denominator, but it is not a pole. Why it is not a pole? If you put s equals minus a, it is not 0, not infinite, it is a finite quantity. And first of all, is this a rational function?
No, sir.
No, sir.
No, it is not a rational function. This is not a polynomial. So rational function means when you express it as a ratio of two polynomials, then you find the roots of the denominator. Those are called poles. Okay, this is not a pole. Okay, so you have to be careful there. First, you have to express it as if it is a ratio of two polynomials, then only we can talk about poles and zeros. Okay, when x of s is a rational function. E to the power minus at ut, its Fourier transform is 1 upon s plus a. And now, once you study these properties of ROC, you can directly say you don't have to remember the ROC here because this is a right-sided signal. The ROC is real part of s greater than minus a. Towards the right of the rightmost pole, here there is only one pole at minus a. So this is the ROC. And similarly for a left-sided signal, this is also a standard results we derived. This is also 1 upon s plus a. And what is the ROC? Real part of s. This is a left-sided signal. So the ROC should be what? For a left-sided signal, ROC is
Left side.
left-sided, and there is only one pole at minus a. So this is the ROC. Okay. Now let us consider an example. I think we started this discussion in yesterday's class. X of s is 1 upon s plus 1 into s plus 2. Okay. By using the standard result, we have to find the corresponding signal x of t. And I have mentioned earlier that the Laplace transform is not complete without specifying the ROC. You can see from here. The algebraic expression is the same, but the ROC is different. ROCs are different. Okay. So the ROC, the Laplace transform, it is not complete without specifying the ROC. So we have seen that there are how many possible ROCs? If you plot this pole zero plot, there is a pole at -1, another pole at -2. How many possible ROCs are there? Let us consider one by one. Can it be a right side? Anyway, it cannot be a two-sided, finite duration signal, isn't it? Can it be a finite duration signal? It cannot be a finite duration signal
No, sir.
because if it is a finite duration signal having Laplace transform, the ROC should be the entire S-plane. Here there are two poles that cannot be in the ROC, so this cannot be a finite duration signal. This cannot be the ROC, the pole zero plot of a finite duration signal. Okay. Now, can it be a right-sided signal? This one. This is one possible ROC, isn't it? It can be a right-sided ROC. Then can you tell me what is the corresponding signal if it is a right-sided ROC by using these results? Can we write, we can use this this partial fraction expansion of this is 1 upon s plus 1 minus 1 upon s plus 2. Okay. So can we use the linearity property, the sum of two signals? We know this is in the standard form. And what is the ROC? If it is this one, what should be the ROCs of this? What type of signal should be this? If x of s is having a right-sided ROC, that means the corresponding signal xt is a right-sided signal. Then what about the corresponding signal? Let's say this is the corresponding signal is x1t and this is x2t. What should be the nature of x1 and x2t? If this is a right-sided signal, what about this? They are also right-sided?
Yes, sir.
Yes. They are also right-sided. They cannot be left-sided. Why not? It cannot be left-sided? Because a combination of a right-sided and left-sided signal, you will never get a right-sided signal. So if the resulting signal is right-sided, these two must be right-sided. And it cannot be a finite, one of these cannot be a finite duration signal also because there is a pole. So it cannot be a finite duration signal also. So these two must be right-sided. Now tell me what is if these two are right-sided, then what are the possible ROCs? First consider this. The corresponding signal is x1t and s plus 1. Is the ROC is real part of s greater than -1? This must be the ROC, isn't it? And what about this? This is also a right-sided signal and the Laplace transform is as 1 by s plus 2. So it is towards the right of the rightmost pole. So here the rightmost pole is at -2. So the ROC must be. Okay. Now tell me what is the using these results? What is the corresponding signal xt?
So greater than -1.
What greater than? I am talking about the signal. This is a signal x1t. What I am doing here is we can write xt as x1t, let's say x1t minus x2t. Is it? Or plus x2t, whatever it be, then the sign will change. We are writing it as sum of two signals. My question is, what are these signals? What is x1t? What is the inverse Laplace transform of this using the standard result?
e to the power minus tut.
It is e to the power minus tut, isn't it? What about the second part? Minus 1 upon s plus 2 and real part of s greater than minus a. Is it minus e to the power minus 2t ut? Is it?
Yes, sir.
So this is one possibility, because we are given only the expression. There are many possible ROCs, and this is one of the possibilities. The signal xt can be a right-sided signal. If it is a right-sided signal, this is the corresponding signal. Okay. Now, what are the other possibilities? Can it be of the xt is of a is a left-sided signal? Can it be a left-sided signal? There are two poles, and we know the possible shape of ROCs. It can be right-sided, it can be left-sided, it can be a vertical strip or the entire S-plane. Anyway, entire S-plane is not possible here. Can it be a left-sided signal?
Yes, sir.
So then what is the possible ROC? Is it this? So then means we are considering one by one. This is the first possibility. Real part of S greater than minus 1. Other possibility is real part of S less than minus 2. Then xt is a minus, then xt is a left-sided signal. Then what about x1t and x2t?
Left-sided.
They are also left-sided. Tell me what are the what is the signal xt in that case?
Minus e raised to power minus t u minus t.
Minus e to the power,
Minus t.
just a minute, minus e to the power. Okay, it is minus e to the power minus t ut, and then
Sir, u of minus t.
u of minus t. You have to use this result. Then minus or plus. There is a
Plus.
minus. There is a minus sign here, so it will be plus e to the power minus 2t u of minus t, isn't it? So that is the corresponding signal if this is the ROC, if it is a left-sided signal. Now, can it be a two-sided signal? What is the possible ROC in the case of if it is a two-sided signal?
Entire S-plane.
Two-sided signal, it is not the entire S-plane. It is a finite duration signal, it is the entire S-plane. And anyway, entire S-plane is not possible here because there are two poles which cannot be inside the ROC. Okay. Two-sided means ROC finite means vertical strip when this is also one possible ROC, isn't it?
Yes.
Between minus 2 and minus 1. This is also one possible ROC, that is real part of S is less than minus 1 and minus 2. This is one possibility. Now, in that case, what type of signal is this? Corresponding signal? If it is a vertical strip, that ROC is a vertical strip, then what is the nature of the signal xt?
Two-sided.
It is a two-sided signal. Then what about these signals x1t and x2t?
Left-sided and right-sided.
One should be left-sided and one should be right-sided. Which one should be left-sided?
S plus 1.
S plus 1, because there are two poles, one at minus 1, minus 2 and minus 1. So this ROC, these poles should be associated with what? This is associated with which one? Left-sided signal or right?
Right-sided.
This is of right-sided signal and this is of left-sided signal. Now tell me what is the signal then?
minus e raised to power minus t u of
Then
minus t.
you can see that this is the right-sided signal, so it is minus 1 by s plus 2, and the ROC should be real part of s greater than minus 2. So it is minus e to the power minus 2t ut, that is a right-sided signal, and this corresponds to the left-sided signal. Then only this intersection, there will be some intersection. Okay. So what is that? Is it minus? What? What is the inverse? If it is a Laplace, if it is a left-sided signal, 1 upon s plus
E
1,
raised to power minus t u
it
of minus t.
is it this is minus or plus?
Sure, minus.
This is minus. So this is the signal corresponding to this ROC. So if you are given only this algebraic expression without specifying the ROC, there are three possible cases here. One is it can be the corresponding signal can be a right-sided signal, and if it is a right-sided signal, this is the signal. Sorry, this is the no. Which one is the right-sided signal? This is the right-sided signal, and if this is the ROC, this is the corresponding signal. And if it is a two-sided signal, this is the possible ROC. This is the signal. Okay.